Hey crazies, you might have heard that black holes suck, like literally. People love to comment this on my black hole videos. Is it a funny joke? Yes. Is it accurate? Absolutely not. Black holes aren't even that weird if you're far enough away. Let's correct this and other misconceptions as I send an expendable clone to his doom. Wait, expendable clone? I didn't agree to this. Oh, thank goodness. He put me in a spacesuit. Don't worry, he's safe. For now. To be fair, some black holes are big, like really big, but those are not common. Supermassive black holes are not the norm. We certainly have one at the center of our own galaxy that has 4 million suns worth of mass. You could fit up to 17 suns across its diameter, and it's small given the size of our galaxy. I have a video on how those might have formed if you're interested. But galaxies usually only get one of those. In the most extreme cases, they get 2. Some galaxies don't have any. The vast majority of black holes in the universe are stellar mass black holes. Our own galaxy probably has on the order of 100 million. And as the name suggests, these are black holes with the mass of a star. The closest confirmed example is Gaia BH1. It's about 1,600 light years away and has a mass of almost 10 times the sun. But don't be fooled, this thing has a tiny diameter, less than 2% the size of the moon. Baby black hole? Do you remember the first time we detected gravitational waves back in 2015? Yeah, those came from black holes that looked like this, 5% and 6% the size of the moon. In fact, given the age of the universe, we only expect to find stellar mass black holes up to about 200 solar masses. That makes for a black hole that's only 34% the size of the moon. All stellar mass black holes are smaller than our moon. Most black holes are small enough to use a city for scale. Granted, they're still pretty big by human standards, but not astronomically. Do black holes have an insane amount of gravity? Yes, they do, but only if you get close enough. Expendable Clone isn't that close at the moment. He's aware that he's falling toward something, but that's it. There's nothing extreme happening. Aside from the lack of light, it could just as easily be a star. Hello? It's not like black holes have a special sucking power or something. Gravity is still gravity. We see stuff orbiting black holes all the time. It's how we find some of them. I mean, look at Gaia BH1 again. There's a sun-like star orbiting it pretty comfortably. That's how we know it's there. And ordinary Newtonian gravity is enough to explain that orbit. The black hole could just as easily have been a 10 solar mass star. The orbit would have been the same. Nothing weird is happening because a black hole is in control. There's no extra suck, it's just gravity. This one is a bit pedantic, but worth discussing. A black hole is defined as a region of space enclosed by an event horizon. It's not the matter that's collapsing, it's the intangible space-time bubble that's formed around it. A black hole has a finite volume that's either a sphere or an ellipsoid. Black balls in space! And it contains a finite amount of mass, which means its density is also finite. Gaia BH1 still has a pretty high density at 23 trillion times that of steel. But it's not infinite, and many supermassive black holes have a density less than air. But what about the singularity? Okay, you want to get into this? Let's get into this. Singularity is not a physical term, it's a mathematical term. It means a point in a mathematical function that outputs an infinite value. But infinity isn't something we observe in the real universe. So historically, singularities always turn out to indicate one thing, that we've stepped beyond the scope of our model. We don't expect the singularity at the center of a black hole to be any different. That singularity probably doesn't exist, but even if it does, it's hidden behind an event horizon. It's not useful to define a black hole by anything we can't confirm. You're allowed to not like it, but that's how it is. We said earlier that a black hole isn't really an object, it's a region of space. That region is enclosed by something we call an event horizon. You know how we can't see past our distant horizon because the Earth curves away? A black hole event horizon is analogous to that, except it's space-time itself that's curving. Space-time is curved so much in a black hole that all futures point inward. So it's true that nothing can escape from inside the horizon, but plenty of things escape from outside. Oftentimes, we'll find an accretion disk, a collection of infalling matter. That matter emits all sorts of light, and the magnetic field generated by it can cause high-speed particle jets. There's also Hawking radiation, which are long radio waves being emitted by space itself. The region just outside a black hole is teeming with activity, yet we still don't see any visible light, and that's because of redshift. Specifically, gravitational redshift. If Expendable Clone were to hover above the event horizon of a black hole, shining his flashlight out into space, we wouldn't see it. The farther we get from him, the more redshifted the light becomes. Eventually, it shifts into the infrared, a form of light we can't see.
Help me!
Black holes redshift light into oblivion, and that's why they're black. Tidal forces are what tend to rip astronomical objects apart. I recently did a video on how this effect can turn moons into planetary rings. It can happen with people too if the forces are strong enough. The official scientific term for this is spaghettification. Don't let that name give you the wrong impression though. It might stretch you out, but it's not going to turn you into human spaghetti. It's going to turn you into human particle bits.
Is that like bacon bits?
Bacon bits?
Humans.
And snack-sized packages for your convenience.
Nothing to see here.
Anything falling into a black hole, whether that be an object or a person, is just going to become an indistinguishable part of the accretion disk. Oh, that reminds me, Expendable Clone is still out there.
Help!
Help! Oh, thanks. I thought it was expendable. Oh, no, that's just a name, you know, for entertainment value. Well, you could have told me that before you sent me out. Anyway, black holes are an incredibly interesting phenomenon, but they don't have to be terrifying. As long as you keep your distance, you'll be fine. And until next time, remember, it's okay to be a little crazy. Several of you pointed out that we're not actually seeing particles. Yes, technically we're only seeing light scattering off of tiny alcohol droplets, but those droplets exist because of the particles. We don't ever see particles directly, but that doesn't mean they're not there. Anyway, thanks for watching.